Good evening, and thank you for coming today. So a quick introduction before our speaker can start. My name is Santosh Harish. There are a few new faces here, so please indulge me while I take a minute to quickly introduce EPIC. So the Energy Policy Institute at Chicago is a research center in the Department of Economics at the University of Chicago. We work in the interdisciplinary space of energy and environmental policy and economics. The foundational goal of the center is to match cutting-edge economics research with real-world impact, and to do this, we try to the extent possible to work with government partners in each of our projects. So currently, we have ongoing engagements with the Ministry of Environment and Forests, the Central Pollution Control Board, the State Pollution Control Boards of Gujarat, Maharashtra, and Tamil Nadu, the state energy departments and DISCOMs, the distribution companies of Bihar, Maharashtra, Rajasthan, Karnataka, and we've also recently started working with the Niti Aayog in Delhi. One of the flagship initiatives over the last year for our group has been the Delhi Innovation Challenge, where we collaborated with the Delhi government to crowdsource interesting and innovative ideas from pretty much anybody, research groups, think tanks, students, anybody at all, to attract ideas that are broadly beneficial to energy and environment in Delhi. So we got something like 250 entries, 250 applications for the competition. Last month, the Deputy Chief Minister announced 3 winners for the competition. And we're really looking forward to get rolling with the pilots there. Today is the 11th talk as part of the EPIC seminar series. The goal here is to basically serve as a forum for an exchange of ideas, debate, discussion. We have so far had speakers from the government, we've had researchers, we've had a couple of journalists as well. And we would like to acknowledge the support and funding provided by the Tata Trust as part of the Tata Center for Development at U Chicago to bring these seminars to you. So today's speaker, Pallavi Pant, is a postdoctoral research associate in the Department of Environmental Health at the University of Massachusetts Amherst. She has a PhD in environmental health from the University of Birmingham, UK, and a master's degree in environmental studies from Teddy University. Her research focuses on characterization and assessment of levels and composition of particulate matter. She has done some very interesting work in understanding the speciation in exposure, and you'll be hearing more about that today. And most of her work has been in developing countries. So outside the lab, Pallavi is also interested in public engagement activities focusing on air quality and health. Given the Delhi smog situation of the last 2 weeks, you would agree that this is an essential role to play for academics working in this space. So with that, Pallavi.
Thanks a lot, Santosh. And I'm really happy, but also really sad to be, here this week. Happy because it's a very good time to talk to people about air pollution and how bad it is. But sad at the same time because this was probably one of the worst incidences of, air pollution episodes in Delhi as far as I can remember. And I mean, I've spent most of my life here, so it has been definitely one of the worst. But hopefully we can try and use this moment to, push the government to take action and also engage people who will definitely be a very important part in any policy proposal that comes from the government or any initiative that they take. So what I've, tried to do today is, what I've tried to do here is just give a brief, introduction to what exactly we're dealing with. And if you feel at any point that, everyone here is pretty okay with it, I can quickly, move forward. Also, if you have any questions or comments as I go along, please feel free to, just raise your hand and then we can have a discussion. I don't want to just stand here and talk at all of you. It would be good if we can exchange ideas. So, just to begin with, one of the things that we seem to sometimes forget is what exactly is air pollution. So, we look at pictures like these and it's, all nice and clean, everything's clear, you can see far ahead. But as mankind, going as far back as the early 1600s, we have known that there is something in the air which is bad for us. And this document was written by John Evelyn in 1620, 1630, somewhere along those time, trying to explain how filthy the air is in London, and that it's because of the factories or whatever industrial action was going on at the time, and that there should be an effort to try and move these away from central London so people could breathe fresh and clean air. And just in London, it wasn't until the 1950s when they had the huge smog incident that they became serious about it. So it is a problem we've had, issues with from the very beginning. It always takes a lot of time for action. And where we stand right now is, in Delhi, especially in winter, air pollution levels are very bad. But this is not necessarily the case just with Delhi. This is happening in many cities across the world. And, if you go to London, it may not look like this, but there are sections in London which are equally polluted. And, the governments there are trying to do things as well. And, I think that involvement of people can help propel that action and make it much faster. And just quickly, in terms of the sources for air pollution, so we always, tend to think of industries and, coal-fired power plants and traffic and things like that. But there's a lot of other ways in which we do see air pollution. So this is a very simplistic version. There are certain things you would expect to see in rural areas, certain things you would expect to see in urban areas. And if I was to ask the audience, I think a lot of people would say, yeah, these are the sorts of air pollution sources we would understand and we would expect to contribute to bad air quality. But then there's a whole other range of sources. What about, all the roadside food joints that are cooking, and what are they burning? Sometimes they use coal. Sometimes they're, frying for several hours at a time. And that may not influence air quality over several kilometers, but if you are in the area or if you are the person that runs that operation, you're definitely getting a very high exposure. Also, probably very sensitive to touch upon, but an important source of pollutants nevertheless is the funeral pyres. They are an essential part of our culture, but they are also something that is contributing to air pollution, and we almost never talk about it. In addition, if we come into the indoor environment, there are several sources that, some people, I'm pretty sure, recognize that they are not necessarily the best part or, best not used indoors, but even things like cleaning products can actually be contributing to poor air quality in your home. And then, this very typical, what are the impacts of air pollution? So we do talk about the health effects a lot. I'm pretty sure most of you in the audience felt to some extent, irritation of eyes or, wheezing, not being able to breathe in the last week when the pollution levels were really high. But in addition to just the health effects, there are other reasons we could be concerned about air pollution. And that includes an influence on our crops. So there have been studies that have shown that very high levels of air pollution, not necessarily particulate matter, but ozone, for example, or sulfur dioxide, for example, can actually lead to a reduction in crop productivity, which, as a country that still has a huge agrarian base, is going to be detrimental in terms of, money. Taj Mahal, probably everyone has heard about, the numerous cases that have gone on over the years on how air pollution is, ruining Taj Mahal, and the most recent case where they banned the use of cow dung cakes in the vicinity to try and improve the air around Taj Mahal. But it's not unique to Taj Mahal. It's truly, equally relevant for other historic monuments or even modern buildings. And finally, the pictures you see at the bottom here, the first one, this one, I took at the JFK airport in New York when I was leaving there Saturday. And this is when I arrived in New Delhi. And both pictures were taken at about 3 p.m. local time. So you can just see visibility was very poor. I know some flights were canceled and delayed during this episode also. So it costs our country a lot of money, and the most recent estimates, I think, suggest that it's almost up to 8% of our GDP, which is a significant fraction. So we cannot really take this lightly. There are so many, variables that are contributing. And really quickly, you've all probably seen this, but just to give, a sense of, it's not always the case that you see the pollution. This, is a typical human hair. And then when you start going into smaller particles, they are much, much smaller. So just because you don't see them doesn't mean they're not there. And this is only particles. There's also gases, there's, VOCs. So there's a whole mix of pollutants in the air that contribute to bad air quality. So, essentially to conclude, why should we care about this is, first of all, because it affects our health. We get exposed to really high levels of pollution, as we go about our daily activities. And that can contribute to how we feel about our urban environments. Do you feel like going out in the park if it's really bad out? Probably not. So it can, lead to physical inactivity because you don't really want to be in a polluted area. At the same time, it affects visibility, so, probably contributing to, you not being able to appreciate the natural scenery around you, or planes not being able to land, and therefore, economic losses. And also, I think we need to make this link much more evident is small particles can often, serve as cloud condensation nuclei, and I will try to explain this really simply. So basically, they can act as a seed for clouds to form, and that would, lead to increase in rainfall over a certain area. But also, black carbon particles can increase the heating, and that is particularly relevant if you think about the Himalayan glaciers, where there is, very rapid melting that's happening. So there's, again, a lot of reasons why we should all care for our health, for our economy, and for the climate in the long term. And several studies in the past have, looked at how population density and pollution levels sort of go hand in hand. So this picture here, if you look at the shades of blue, they basically represent the population density. Oops, I'm sorry. They represent the population density, and then the circles represent the PM concentrations. And as you can probably guess, the areas with the highest population densities are often the areas which have very high PM concentrations also. And what that essentially means is that large chunks of, the population are often exposed to very high levels of air pollution, and this is particularly relevant for the developing countries. So if we look at, the average PM2.5 concentrations globally, we again, see that same trend. Parts of Africa and Asia are where the highest concentrations are, and they are the same parts where the most number of people are also living. So if we then try to see, all right, so we have really high concentrations of, PM2.5, is that really causing, problems in terms of health? And the simple answer is yes. So this graph essentially represents mortality rate. So how many people are dying due to air pollution exposure? And again, India and China and parts of Africa light up because that's where a lot of people are. That's where a lot of pollution is. And to answer questions of what and how, and do we know what the levels are, there are many ways we can try to measure air pollution in our environments. And of course, there are a lot of research grade instruments or equipment that are used routinely by scientists. But more recently, there's also been an advent of low-cost sensors, which are making it really easy for anyone to go out and see what the air quality looks like. And in fact, in the last 1 or 2 years, I think there has been a number of low-cost sensor networks that have come up. So there's India Spend, India Open Data Association is putting their sensors in a lot of places. There are chatbots that can tell you what the pollution concentrations are in your, area. And I will come back to this a little bit because there is also need for us to be a little cautious on what kind of data are we, receiving? How do we interpret it? What does it mean? But for now, so if we only look at PM2.5, that kind of gives us a picture of what the air quality looks like. Is it bad or is it not too bad? But often the devil is in the details. So, what is this PM made of? How much metals does it have? How much of it is carbon? All of that becomes very relevant. What kind of gases are in the air? What are the ways in which they are reacting? And I cannot emphasize enough that it is not a single pollutant that is going to, cause harm, and it is not pollutants just acting on their own. There's a lot of complex chemistry that goes on, which contributes to some of the increases in the pollution levels. And then the next, logical question would be, okay, so if you have a lot of air pollution, if you know that there's, metals and carbon and gases, what does that really mean in terms of my health? So there are chronic and acute health effects. So chronic, based on long-term exposure. So if you live in Delhi for 25 years and you're continuously exposed to these very high concentrations, what are the health effects? So, there are instances of asthma and cardiovascular disease incidents, but there are also acute effects. So if you are exposed to very high levels, but for a short period of time, you can still see effects like wheezing or just coughing, irritation of the eyes, things like that, all of which I actually experienced last Sunday. So, I felt it firsthand. And, I'm pretty sure some of you in the audience had the same experience. So in order to try and understand how do we measure these health effects, what do we mean by these health effects, and how are they actually causing these changes? Why does exposure to, let's say, copper in the air lead to an increase in my blood pressure levels? Don't quote me on this. This is just an example. But there are a lot of relationships like that, that often drive these health effects. And there are two major ways we can learn more about them. One is through epidemiological studies, where you look at large groups of populations and you monitor them for a long period of time, and you try to see how they're, whatever your endpoint might be. You might look at pulmonary function. You might look at, incidence of a myocardial infarction. It really depends on the kind of assessment you want to do. The other way to look at it is to go deep down and say, if I get exposed to this PM level, what is mechanistically happening? What is the reaction that's happening in the body? Does the body have a natural reaction to protect me from it? And yes, there are, ways and mechanisms for our body to protect us from it. But there are also ways in which it's really helpless and it cannot. So a number of people are doing some very good research trying to understand what these health effects are. But our problem is a lot of what we know comes from the developed world, where pollution levels are much lower. So, if we go by those estimates, we should all probably be really sick right now, but we're not. So, a lot of effort is also being spent on trying to understand what does it mean to have really high exposures for longer periods of time. Do we adapt to it in some way? And one really interesting campaign that comes to mind is, I think a few years ago, a group called Clean Air Asia ran this campaign where they were selling these not exactly masks, but they were just plastic noses with really long nose hair. And they said, over the next 20, 25 years, our body is going to react to these high levels of air pollution by just making our nose hair longer. And I don't think that's going to happen, but it was a good way to catch people's attention and, get them engaged. So, it's, not science alone can get people involved. We need things like these. But I think that was an extreme way to do it, but definitely got people thinking what air pollution does to them. So focusing now just on India, these are predictions for PM10 and PM2.5 concentrations over the country. And they are, of course, based on some estimates, some, statistical modeling analysis. And as you can see, so one thing I want to point out is here the scale starts from about 10, but here, we are sort of at 25. And again, this part, the northern part, mostly the Indo-Gangetic plain, in India tends to be the most polluted for a variety of reasons. And this prediction, or these average concentrations are actually for today. So if you're interested in checking what the daily predictions for Delhi look like, you can visit this link at the bottom. I think it's delhiairquality.info. They always have like 3 days of predictions on what the air quality levels would look like for, I think, 540 districts in the country. So it's pretty interesting. But also, if we just look at, coming back to the big cities, Delhi, Calcutta, Mumbai, Chennai, this data set is from the US consulate monitoring stations, and I just put it here to show the average trends across the cities. And what is really important here is the scale. So if you look at Delhi, the concentrations at the highest go up to about 500. Whereas if you come to Mumbai, it's only going up to 150. In Chennai, it's only going up to 120. So there are obvious differences as you go across the country. And, some of the differences are also driven by where the monitor is located and, lots of other things. But overall, there is definitely relatively higher levels in Delhi. So that, yeah.
Can you just go back to the previous slide?
Sure.
Just wanted to better understand, we're looking at this map with emission levels. How many monitoring stations, or how are we actually mapping this now?
Okay, so that's actually a really good question. So these are modeling estimates which are not based on actual monitoring on a day-to-day basis. The model is adjusted for the ground measurements. So you take 2 years worth of measurements from 7 stations across the country, and then you try to adjust your model for whatever the ground values look like. And based on the comparisons with ground level monitoring stations, more recently, these predictions are, almost there. They are model estimates, so there is uncertainty, absolutely. But I would say that they are the best that we can do so far. Yeah.
So why do you do it that way rather than use satellite data if you only have 7 ground stations?
Oh, so, okay. 2 things. First of all, I'm not really doing this, so I'm not sure what the specifics are. I just, put it up there to show people that this is a resource that is out there. But I don't think that it is just the ground stations. The ground stations are just to say, okay, it sort of makes sense. The model isn't giving out random numbers, but they are using WRF-Chem and metadata and from, other global models. And to a large extent, it has been, to the extent possible, I should say, it has been verified with local emission inventories in at least the major sections of the country. So, as I said, this is as close as we can get at this point. And of course, there are, numerous ways in which we can improve this model. And, the people involved here are obviously trying to make it better all the time. Does that answer?
Strengths of modeling air quality levels vis-a-vis satellite data-based estimates. And for one thing, these also give you forecasts, which obviously satellite data cannot. But are there advantages in terms of techniques, in terms of limitations of what satellite data can and cannot do?
So essentially, I would say we need a mix of all of them. So the satellite data is really useful to try and look at, okay, if I saw really high levels in Delhi, what was going on? Where was the air mass coming from? We need models so we can say 2 days from now, we are going to get an air pollution episode. We need to tell the people so they can be, they can protect themselves, not go outside, try to minimize their exposures. And then the other important bit that, I will touch upon later as well is that we need better monitoring. And none of the models would get really good unless we can say, okay, if our model gives us a concentration of 35, we are actually able to see a concentration within 10% of that number. Satellite data for the Indian situation in particular is very helpful, especially because we do not have a wide coverage of monitoring stations, and a lot of the estimates on mortality or morbidity effects in India are using satellite data, because that is the way that we can get regional estimates, and we can try to go down to say one kilometer by 1 kilometer in certain cases. And in the absence of the satellite data, we would probably be more environment for much worse off in terms of what we can estimate. Does that answer your question? And did I answer your question?
Does
Oh.
the model use both ground stations and satellite data? I mean, that would seem like the optimal.
So the model, I don't know the answer to that. Yeah.
They use thermal and satellite.
Yeah.
This model actually does use satellite data. But one of the problems with satellite data is that is also a model, in the
Yeah.
sense that you measure what's in the what's through the whole vertical, and then you have to model what must be on the ground. So
Which is why you usually want ground stations.
Right.
And there's one more limitation that when you have weather, cloudy weather, you cannot use satellite data. You don't have the satellite data
Yes.
on cloudy weather.
Yeah, that's a really good point, because that often leads a lot of the satellite data to be discarded because you just don't have the right specs you want. Okay, so I mean, the point that I wanted to make with this slide was just that there is a huge variability. So even when we come to the point where we say what are the kind of policy actions that are needed to reduce air pollution across India, the solutions cannot be just we're going to do this one thing. There are solutions which will help across the nation, like the Bharat 5 emission norms, or trying to regulate the coal-fired power plants better. But at the same time, we will need more localized solutions. For example, if we consider Delhi, there are a lot of things that happen mostly around winter, which probably are not necessarily relevant for Mumbai or Chennai. So we don't need to say, and across the country, you need to do A, B, and C. So we will need to develop more regionalized and targeted policy actions so we can successfully reduce these numbers over time. Another thing which is very important and sometimes kind of gets lost in our conversation on air quality is what is the size of the particle that is out there. And this is important both because of its health effects, so the smaller the particle, the deeper it can go, but also because how quickly the particle can be removed from the atmosphere depends on the size. And unfortunately, in the Indian context, we do not have a lot of data to know what's really going on. Particles can be formed de novo. You can have smaller particles coalescing to form larger particles. In Delhi, one of my studies earlier was to try and look at what's happening to particle size distribution in the winter. And we saw that a lot of the sulfate, which was being emitted on the road, was actually showing up as slightly larger particles than we would expect. And in winter, relative humidity levels are very high. And so that's a very plausible explanation, and we are pretty confident that that's what's happening. But that was one study. We need to learn more about this and try and understand what's happening in Delhi, but also elsewhere. And again, depending on the kind of the particulate matter component, you can see certain things to be more prominent in the coarse fraction, so like the bigger particles. For example, the dust particles would definitely have a lot of silicates, aluminum, iron, but you're likely to find a lot of the zinc and the lead, which is particularly toxic, in the fine fraction, which is smaller particles. They stay suspended for longer. You're more likely to breathe them in. And this particular example is, again, from Delhi. And if you notice here, all of the red section is primarily the fine fraction, so anything that is smaller than 2.5 microns. And elements like, copper and zinc and lead are all in the fine fraction. So that's the kind of stuff we're breathing in. And when we start thinking about protection or mitigation, we should be considering this. One of the interesting things which I have seen, in all of the different analyses that I've done, is really high lead levels in the air, which in the first instance was a little surprising because we would expect to see some amount of lead. We banned gasoline a couple of decades ago, I think, but there is expected to be some bit of it, still in the atmosphere, which gets occasionally resuspended. But the kind of levels we saw cannot be explained by that. So what is the reason we have all this lead in the air? And there's a couple of explanations for that. We're not entirely certain if that is the case, but lead acid battery recycling in the city, which is largely unregulated and mostly in the informal sector. So I don't have numbers on that. I would love to hear from anyone here who might know more about it, but also incineration of waste in the city that might be contributing because a lot of the waste is not segregated enough.
Paint in this, the yellow color,
Oh, okay. So the paint on the roads.
anywhere.
Oh,
It is the yellow ones.
yeah.
I recently saw a talk at the American Aerosol Association. They had daily filter samples, and they also had the same conclusion of high lead concentrations.
Oh, yeah.
And so it was basically from burning of lead batteries.
Right,
Yeah.
right. So, yeah, if anyone here looks at air pollution from any lens, I think that is a question we should probably try to focus a little bit more on.
Waste incineration contribution is pretty low.
Okay.
Comparatively.
So what would be do you have any sense as to what might be the...
I've compared urban and.
I'm Sudhanshu, and I've just finished my PhD from CSIR National Physical Laboratory. I have done my research on the emissions from the waste incineration.
Oh, okay.
Yeah, in that I compared the metals from the waste burning, open waste burning, and of the urban places, and the concentration of lead was comparatively low, though it was not very low, but when we compare it with the urban sites, it was lower. It means that the lead, what we are getting in the urban aerosols, they have additional sources apart from the waste incineration,
Okay.
as we are talking about
Yeah.
battery recycling and other things.
Okay. So yeah, that's, understanding not just the PM levels, but also trying to drill down into what exactly is this PM made of is going to be really useful in, first of all, understanding what are the sources, because none of the source apportionment studies or inventories are probably considering the lead acid recycling in the city, but if it is contributing to the PM 2.5, that is something we should be looking into in more detail. And then really quickly, I just wanted to, go through this very controversial study, and I'll get to why this was controversial. But there was a study that looked at PM 2.5 levels in the entire country, and again, it was based on modeling estimates. They did not collect samples, throughout the country. It's just, too expensive, too time-consuming. So they used modeling analysis to calculate what the average PM 2.5 levels are. And then based on that, they said, okay, so if these are the levels of PM 2.5, this is where a majority of the deaths are happening. So, the color scale is pretty similar. It goes from low to high as you go from blue to red. And this is the mean, where is the population of the country. And then when you come to premature mortalities due to PM 2.5 exposure, mostly in the Indo-Gangetic plain, and then there are other pockets through the country. Similarly, when you look at premature mortalities due to ozone exposure, we are not looking at ozone in detail at all, but we should be trying to, understand this better as well. It was the Indo-Gangetic plains where most of the mortality-related, the exposure-related mortalities were happening. However, our environment minister at the time rejected this study completely, and he said that's because it's based on modeling. We do not know what the real numbers are, and therefore we will not believe this. So, it's really unfortunate that we cannot always start with a perfect study. We have to start with what we have and then build on it. But this was the stance of the ministry, and the people involved in the study were told to not talk to anyone about it anymore, and just basically put it away somewhere. But other studies done by different investigators, not the same group, have come to similar conclusions. So again, PM2.5 concentrations on this panel, really high levels in the Indo-Gangetic Plain. When you come to, how vulnerable is the population to this exposure in terms of mortality or morbidity effects, similar, pockets identified as sensitive regions. And then again, if we try to look at the mortality, these numbers are similar. Similar results have been reported by the Global Burden of Disease study. And their absolute numbers are not going to match. They're not going to be the same because everyone uses slightly different estimates. But it's pretty clear that there is a significant mortality burden. So basically, a lot of people are dying, either dying early or getting a lot of disease burden because of exposure to air pollution, and that this is one of the most important environmental health problems. Did you have a question?
Yeah. Can you tell me how we arrive at what is the definition of premature mortality here?
So premature mortality would basically, so let's assume that average age of an individual is about 70 years. Premature mortality would be if you died at 55 and you would have lived to 70. And if there's anyone in the room, who can elaborate on that, I would welcome their input. But it's basically calculated on average ages, and it obviously differs from country to country. And, they try to bring into it the cultural, genetic factors, things like that. And they calculate premature mortality primarily from an estimation of, I expect this person to live to the age of 70, but they didn't live to the age of 70. They died, earlier, and try to correlate exposure to air pollution to that.
And how would you link it to?
Does it relate it to any disease or something?
So yeah, when they calculate the mortality burden, it's not, it's not directly like, okay, this person's dead, because there are many reasons that could contribute to this. So they often look at a number of health endpoints, like, did this person have any cardiovascular disease incidents or respiratory diseases or any other, diseases where we know there is a link between exposure to air pollution and, either a person dying early or, yeah.
Yeah, and at the same time, when we look at our records in terms of who's died of what disease,
Right.
our understanding of that in India is also not very good.
No, it's very poor. Our understanding of that is very, very poor.
Statistics you will get in India, it will be under mentioned, because most of the data which is obtained in Indian hospitals, they are the lucky people who go to hospital.
Exactly.
Most of the people, they are not being able to go. They can't afford that kind of medication where systematic study and recording has been there. So they die on road or die at their home, and they are suffering actually. So it will be always remain under noted.
So do you think these mortality related incidents are underreported and so they're understated here?
I think for me that's a little difficult to answer.
If I may,
Yeah.
Pallavi, could you talk very briefly about how the mortality estimates and for air pollution?
Yeah, so I mean, just to add in one more data point, so we published a paper recently, myself and some co-authors, using satellite data and some estimates from the economics literature from China and other developing countries to sort of answer this same question. So it's a completely different methodology, and
Yeah.
we actually came up with a number of about 3.2 life years lost. So there does seem to be kind of convergence on that in different ways, which lends some credence to that estimate.
Thank you. So one more, really quick point I would add before moving on is that a lot of these estimates are often based on the data that is available today. But the global burden of disease, which is an international, initiative, I think there's almost 500 experts from across the world participating in it. They do a revision of these estimates every, I think now it's every 2 years almost, and they try to use the latest data available. So when this was done, 10 years ago, probably the numbers were very different. And maybe 3 years from now, the numbers will again be very different because our understanding would have improved, we would have better data, and without a doubt, in a vacuum of information, a lot of the assumptions in these kinds of assessments are based on what we know and how best can we use that information to estimate what's going on. So to answer your question really simply, there might be under or overestimation, either is possible, but this is the best that we can get to with what's available right now. So then I really quickly wanted to touch on the issue of dust because it always comes up when we talk about particulate matter levels, and one of the initiatives of the Delhi government also has been we're going to control construction dust and we're going to control road dust by doing vacuum cleaning. And those are good initiatives. Construction dust is a big problem and it's highly uncontrolled. But in addition to the dust, construction sites are also a problem because of the heavy machinery that is used, which uses a lot of diesel fuel and can cause a lot of particulate matter emissions. But to simply call it dust is an understatement because if you think about dust as just silica particles which are naturally occurring, an argument can be made that it's not too bad for you because it's just there and it's natural. But we have to understand that those silica particles will get coated by whatever is being emitted. So if you measure road dust, you're going to see a lot of zinc and lead on those dust particles, and they're on the road, so they're getting resuspended. So what you're breathing in is a very dangerous mixture of toxic chemicals which are on the dust. So if we are trying to talk about dust, so this is an example, or one of the samples I collected in Delhi about 3 years ago. The dust loading per square meter of road area was much higher than what we've seen in other parts of the world. So dust is an issue. It is something we need to control, but we need to be mindful of how we describe what dust is and how bad or dangerous it is.
Could you explain that number, please?
Yeah, sure. So
Meter square is area of what?
So basically we the way we design this is we take 1 meter square of a road surface, and then we try to see how much dust is within that meter square to just get as normalized numbers as possible. And so what this would mean is that in 1 meter square, you have about 73 milligrams of, PM10 dust. So this is not total dust. This is only the PM10 fraction of the dust. So the actual, total particle number or the particle mass is going to be much higher than this. This is just the PM10. So likely to be suspended and likely to be inhaled to some extent.
And this is uniformly across the road or at the curbs?
So this is averaged going from the curb to the middle and then from the middle to the curb. So trying to cover the whole surface of the road. And now I want to, quickly talk about personal exposure. So we have all these estimates on what the ambient levels are. We know that they're very high. But what does that really mean for us when we are, probably staying indoors most of the time, working or, staying at home? And when we think about personal exposure, we, typically as a scientist, I would say, I will look at the concentration of any pollutant in this room, for example, and then I will take into consideration that you spend 6 hours in this room or you spend 2 hours in this room. And then I will try to calculate what your personal exposure level is. And of course, because all of us do things differently and at different times, we are going to see differences in our personal exposure levels. So the concentration in this room for PM2.5 might be 30 micrograms per meter cube, let's say. But I spent 5 hours here, you only spent 2. So that's going to change, how much we got exposed to this, indoor PM2.5. Another example would be, one thing that I've seen in my study, for example, is women who are also cooking tend to have higher exposures, even in urban households. Now, I'm not talking about rural households where they're using solid fuels. This is urban households where, women are cooking with LPG, they have some degree of ventilation. They still have higher exposures because they're the ones who are in the kitchen for 2 hours, whereas the kids are probably not there and the men are probably not there. Also, your occupation and your socioeconomic status is going to make a difference because it will determine where you live, how you travel, and the kinds of things you do. This then leads into a bigger issue of environmental justice, which I will touch upon really briefly. So again, to drill down into the point of different exposures for different individuals, if we consider this example, this is Chandni Chowk. And if we were to estimate personal exposure for a rickshawala who, spends probably 8 hours a day on the roads, which are full of traffic, his exposure levels are way different than mine, who probably spends 10 minutes on that rickshaw and then is, off doing other things. Similarly, this is actually very interesting. So this picture I took in Mukteshwar about a year ago, and this is a dustbin that is provided, but everyone puts the trash here and they burn it once a day. And it's not because they don't want to use the dustbin, it's because this dustbin is never emptied. There is no way you can do anything with that waste. So initially they used to put it in here, it would overflow, everything would fall out. So they came up with a better solution that if we just make a pile here and just burn it at the end of the day, it solves our problem. There is no waste at the end of the day. But there are vendors sitting in a row right next to that and selling fruits and, snacks, and they're breathing in all the dioxins and the metals and the PM. So if we, again, coming back to the Delhi situation, if we want to ban burning of waste in the city, it is not going to solve our problem. We need to have a good waste management plan. We need to know where this waste is going to go, how will it be disposed of, and that's when our problem is solved. Our problem is not solved by banning crop burning, not solved by banning waste burning or leaf burning. So the solutions for controlling air pollution have to be sustainable. And another, example of a personal exposure for an individual. So this is the PM2.5 on top, and this is black carbon. And this is over a 1.5, 2 day period. And what you can see here is that all the spikes in the, exposure profile happen either when the person's commuting or when, so this was a female, she works, but she also, she commutes with a car, so her PM levels are maybe not that high, but she does have, black carbon exposure, which is relatively high compared to her baseline. Then she also does cleaning, so like dusting and vacuuming and things like that. You can get high peak exposures at the time. And then this is when she was stuck in the traffic, got home, and immediately started cooking. And for about an hour or 2 hours almost, her PM2.5 levels were just really high.
Did you get her to walk around with a sensor?
Yeah. So people walked around with like 2 instruments for 2 days and then told us what they did at what time. So we were able to go back and say, oh, so they were traveling at this time, and we see a peak level. And so the highest concentration I saw here was around 3,000 micrograms per meter cube or 3 milligrams per meter cube. I think that makes a bigger point. And I think this past Diwali, the highest concentration, not averaged over the whole day, but just a peak level, was somewhere around 3,500 micrograms per meter cube. And that was in the ambient air. That was not someone's personal exposure. That was just the ambient air level. And, just continuing on the subject, depending on what you do and who you are, your exposures are going to vary based on what kind of microenvironments you spend most of your time in. But as a general trend, we saw that commuting is a big component for black carbon exposure. So you're on the road and there's a lot of tailpipe emissions, so you will see a lot of black carbon exposure here. And otherwise, it's mostly the indoor environment, so your office or your home. And then it starts becoming important, like, where do you live? And do you keep your windows open? Or, are you sitting in an AC the whole day? Those kinds of things start becoming very important in terms of yeah?
These are all samples taken from Delhi?
Yes, these are all samples taken from Delhi.
Sorry, when you
Yeah.
say black carbon, do you mean PM10s?
So black carbon is soot, the tiny like black particles. So they would be very small particles, 2.5 or less than 2.5.
But as like a single, instead of PM2.5, it is a bunch of chemical constituents.
It is one of the components.
One of it.
Yeah.
It's actually technically, it's that particular matter which absorbs light at a particular wavelength.
Yes.
which is close to
So it's a technical definition for a type of carbon particle. If we want to go into the details, and you can define it differently. So there's black carbon, and then there's brown carbon, and then there's soot, which is just like the general explanation. So just an example of if you were commuting, what are the different ways in which your exposures can be higher or lower? So it would depend on the time you spend in commuting, what kind of commute mode you use, what is the fuel type, did you get like really good traffic conditions, so you weren't idling for a long time or braking every 5 minutes.
Excuse me?
Yeah.
Could you just go back to the previous slide?
Yeah, sure.
So have these been mapped against the amount of time people are spending in these microenvironments?
Yes, exactly. So the y-axis here is the percentage of total exposure. So we take into account how much time did each individual spend in which microenvironment, and we calculated the total exposure, and then we parsed out, they spend X amount of hours in the kitchen, so this is how much the contribution from the kitchen is, or they spend this amount of time in their office, so this is what the contribution from the office is, and so on.
And would this be gender specific?
So the different subjects here are male or female. So it's a mixture. I mean, I don't have only males or only females. It's a mix of both types.
Activity specific more than gender.
Yeah. I mean, we do see gender-specific differences because I didn't really see, very high cooking exposures for men as opposed to, women. Commuting time was pretty much the same between both because most people that we sampled were going to work and coming back, so it wasn't a big difference in terms of, how long they commuted for. It was pretty much similar. And for the office and the house, it really depended on how long they were spending in those environments. Some people lived really close to work, whereas some people were, commuting 2 hours a day. So that sort of thing made a difference more than male versus female.
Other very minor factors are there, rate of breathing actually.
Yes, I mean, so this is just the
Age and also number of breaths per minute. As it differs, as it is more, you take more. So it is more with the children and
yeah.
aged people because they are gasping for air.
So the moral is spend more time in the office rather than the kitchen.
Depends on your office, depends on your kitchen. I mean,
Daily wage laborer.
yeah.
If you're a rickshawala, then your office is not as.
Yeah, it's not gonna help.
Yeah.
So what I'm trying to understand, and probably I'm not understanding this graphs too well, is what is the intensity of exposure per, say, unit of time spent in each of these microenvironments?
Could you maybe go to the previous slide that I just walked it through how?
Okay, so I understand what your question is, and that exactly will not be answered by the slide I'm showing after this. So you are trying to understand what is the highest exposure or where is the most exposure in terms of highest levels of, let's say, PM2.5, right?
Yeah. So it has to be a function of how much time
You spend in each, yeah.
How bad that is.
Exactly. So to answer your question without looking at this, I can tell you that if you're spending time in the kitchen and you're commuting by auto rickshaw, that's the worst. Because when you're traveling by an auto rickshaw, you're sitting really in the middle of the tailpipe emissions and you're breathing in all of that. One of the interesting things we found here, and I don't want to push it a lot because I'm not sure if that's a reasonable finding, is that if you're traveling in buses, your black carbon exposure is actually much lower. And the idea is, you're relatively higher from the ground level, and the buses are CNG, so there isn't self-pollution like it would be in case of a diesel bus. So that might be driving down. Yep.
This is a question about monitoring that. So imagine the position, if there's a difference between like being at a bus level and being on the ground, what about the positioning of air quality monitors across the city? How accurate are they for measuring ambient air for somebody who's say 5 feet off the ground rather than?
Okay, so that's a very interesting question and something that a lot of people have studied. And in general, you can't really answer those, very specific microenvironment questions with an ambient air quality monitor. But overall, if you have a good spatial coverage, you can, more or less estimate what the exposure are. And this is based on, assuming people are spending X number of hours. So it's not going to be efficient in saying bus is this much and auto is this much, but it would probably be okay in saying on average this is what the exposure level is. Yep.
So you're mixing indoor and outdoor sources in this, right? So for example, in your kitchen, you're talking about your local LPG stove, whereas in your office, it's probably mostly ambient air come inside, right? But if there are people smoking, then not, right? So it's a very mixed picture, right? Whereas the global burden of disease tries to differentiate indoor and outdoor sources, right? So do you have any sense of, for a Delhi person, are they mainly being exposed to indoor or outdoor pollution in their actual life?
Right. So we tried to, recruit people who do not smoke and who worked in conditions where, so all of them were using LPG, all of them, I would say it was very representative of the middle class. I wouldn't say that it was representative of, let's say the laborers who are probably spending a lot of time outdoors or are using solid fuels. And we are not trying to differentiate between indoor and outdoor sources specifically because we are not dealing with a population that has a lot of, solid fuel use. And the idea for this was to see on average what is the exposure level for an individual who has pretty much, the same type of pattern. So they go to work, they come back home, they cook and they probably, go out. What is their exposure as opposed to trying to understand, what is happening if you have solid fuel use and, because that just makes it a lot more complex and really a different subset of the population. Does that answer your question? So I'm not trying to estimate.
Right, but you still have the smoking problem, right? Some people work in offices where there's lots of smoking and other people don't.
In this group of people, there wasn't anyone that worked in an office where there was smoking indoors, yeah. Yep.
Just a quick question. Did you have anyone who rode the metro in this?
Unfortunately not, and that was simply because the security at metro stations wasn't comfortable, and the individual wasn't, we had a person who was, who was always commuting with metro, but the first day he took the instruments, they just sort of were like, no, what is this? Why do you want to take this? And
I actually tried to get someone to do that, and the same thing
did it
happened.
work?
I actually have a paper comparing different microenvironments and the exposure to PM2.5, and I snuck in my dust track, which is used for monitoring PM2.5 in the metro as well. And we see that the exposures in the metro are close to 1.1 times of what they are in the ambient air. In this case, the ambient air was the IIT Delhi campus. And like she said, auto rickshaws are the worst, and there we saw the concentrations being 1.3, the exposure being 1.3 to 1.4 times of what you see in the ambient air. And then buses are in between like 1.2, and then AC cars are the best. Like there you are breathing close to like 0.5 times what you would breathe in the ambient air, which is because of multiple reasons like area to volume ratio and different reasons of
and very high levels.
We actually, that was also there. In that case, it's close to 1.1. My name is Shazad Ghani. I'm a PhD student at the University of Texas at Austin. I did my undergrad degree from IIT Delhi in civil engineering, and I have been working on air pollution for a few years now.
So yeah, if you can sneak in more of your sensors into the metro, that would be very interesting, because studies from other places, like not necessarily India, have found that subway levels of PM or even some of the metals are actually very high because it's a closed environment. There's not a lot of dispersion because you don't have fresh air. So the concentrations can exceed what you would expect to be normal levels even in ambient air. So yes, if you do that, I would definitely love to see. Yeah.
Yeah, it's just a black box with a blinking red light.
Oh, you need to turn off the instruments while it's going in the X-ray.
Ah, okay. So that's the trick. Now we know.
Don't tell them I did.
Okay, so to answer your question partly about solid fuel use versus LPG use in different parts of the country, this is a study that Kalpana Balakrishnan did, who's sort of the person for household air pollution and epidemiological studies in India. And there was a very clear difference. I think no one here would be surprised that if you're using solid fuels, you would have a much higher exposure level as opposed to LPG. And it would be interesting to see how, introduction of LPG to a large number of households across India is going to change this picture over time. But I haven't, spoken a lot about household air pollution today, partly because I was trying to cater to the audience that was here. But household air pollution is a huge problem, especially in rural areas, but also increasingly in urban areas. So I was at a workshop, until yesterday, where someone was saying that due to rapid, migration from rural to urban areas, there's a lot of people who are traditional solid fuel users, and they're living in sort of marginalized areas of the cities, and the solid fuel use might actually be on the rise to some extent in some of the cities, but mostly driven by these patterns or like waves of migration. So it would be interesting to see how that goes. Yeah.
Was the data about exposure and mortality, did that reflect HAP data as well, or just outdoor air pollution?
Do you mean the data I showed earlier with the maps? So I think one of them was purely ambient. They are not taking into account the household air pollution. But the global burden of disease study, which I didn't show here, actually separates ozone exposure, PM2.5 ambient exposure, and then household PM exposure. So it does like all three. And then, coming to Delhi, talking to a Delhi audience cannot go without introducing some of the Delhi stuff. So this is PM2.5 concentrations from two separate stations that are run by the Delhi Pollution Control Committee. The first one here is Arkipuram, sort of like a residential / traffic site from what I understand. Anand Vihar, much more polluted, much higher levels. And again, this scale here goes from blue to red, and red indicates really high levels. What is interesting here, again, is this scale goes up to about 500 to 600. This scale goes up to about 800. And there is an increased or like an increment in the overall PM2.5 concentrations here. But as I'm pretty sure all of you know, really clean, I mean clean in relative sense, not absolutely clean, but as clean as Delhi can get during the monsoon period, so July to September. You see that at both the sites, but then really high numbers during January, November to February, basically. And so I really wanted to, add this because I think we need to keep talking about the Delhi air pollution episode and make it the big thing, which helps us push the government to introduce changes. And, I'm absolutely, not really absolutely sure, but I know any change introduced today is not going to make things different tomorrow. But we have to start making changes today so things would be different 5 years from now. And I just have data from 2 sites here again. So this is Anand Vihar. And now the period is only from October 26th to November 7th this year. So, Diwali is right here. You see these really high levels. And then it kind of goes down. There's some missing data, which, is just sometimes you do have missing data. I really can't do anything about it. And I will also add that I haven't really looked at this data very carefully. I just downloaded it today, and I wanted to, just check quickly what the levels look like. And then this was the data from the US consulate monitoring site, which is in a relatively cleaner location compared to Anand Vihar. What struck me was here the levels go up as high as about 1200. And this is hourly measurements, so you're taking measurements like 10 a.m., 11 a.m., and so on. But at the Anand Vihar site, the highest concentration is only about 850, I think. Not sure what happened there, but something, yep.
I think it's difference in sensitivity of instruments.
Sensor.
It's the U.S. Embassy is using a more sophisticated measure.
So it's the same instrument.
Both of them are redefinition monitors.
Yeah. Yeah, I wouldn't comment on this right now, but I think.
That DPCC doesn't want to show the actual data. That's what we want.
I'll move on. Yeah. The thing is also like, as I said, I haven't really looked at it in a lot of detail. What you're saying is probably true, but we do need, a more quantitative assessment.
I would like to make a quick point on this, and I think Pallavi would agree. I think it's important to say that DPCC is actually one of the very good sources of PM2.5 data that we do get from Delhi. So even though it may not be perfect data, we have to understand that this is open data, we can get it, and it's one of the best data sources long-term that we have from Delhi, apart from the US Embassy data that you showed earlier.
Yeah. No, I completely agree with Shahzad, and not just Delhi, I think across India, the Delhi Pollution Control Committee is actually doing a very good job of collecting and making the data public, which is, another issue. A lot of people collect data, but you just don't have access to it, so you can't even tell if it's good or bad. Yeah, I hope that, we will continue to look into this a little bit more detail, because meteorology will play a role, and these are just the PM numbers, so hopefully we will be able to analyze it in more detail and try and understand what just happened. So I think, when the whole thing was happening, there was a spike in the number of people trying to get masks, and shops were running out of masks, and everyone was, questioning, should I be running around with a mask, or, should I just shut myself indoors? So I just thought I'll put this out there. There is a lot of, different studies that have been done, not as many as we would like, but there are some studies out there. And typically, depending on the type of your mask and considering the kind of air pollution we have here, the efficacy of the mask is going to be somewhere between 15 to 50%. So if you use a surgical mask, you are not really doing yourself any favors, because it's not going to help you. If you're using an N95 or an N99, yes, you will have some protection against particles, zero protection against gases, which is really important to understand also. And the other thing is, how well does the mask fit your face is really important, because otherwise you'll just have a lot of, air going in, not through the mask, but through the side. So that's another important thing that I just wanted to emphasize. So if you are using a mask, it will probably help you to, filter out some of the particles, but just make sure, that it fits your face really well, and that you're not using a surgical or, a simple cloth mask, because those definitely do not work.
So are those charcoal-based filters masks, are they any effective for gases?
HEPA filters.
So HEPA would be for particles. There are some that are gas phase, but I think I'm not sure. I mean, if there is a charcoal base, probably, but from what I have seen.
I got it from Smart Air recently.
Right.
Said that charcoal is there?
I mean, I don't know how long that's going to go. I mean, the charcoal one, it might just saturate really quickly. I don't really know what kind of mask that is, so I wouldn't want to, just put them off and say, no, they actually don't work. The other question is air filters. That was, again, one of the things that a lot of people were talking about. And I am not an expert on which air filters work the best. So what I thought I would do is just quickly explain the different kind of air filters that are out there and what they can and cannot do. So the most simple types, particle removal filters, so the ones that would use a HEPA filter, for example, will effectively, remove the particles that are in the area where you are using this air filter or air purifier. Those have been, in some studies, shown to be effective and actually in, helping reduce the particle concentration to some extent. The second ones are again, any particle removal filter will not do anything for the gases, so it's only effective for particles. The gas phase air filters do the same thing, but for the gases, so they will try to, they will try to absorb or just, remove any gases that might be present in the air. And then the final category, which I think is probably the most dangerous, is the pollutant destruction. There have been a few ozone air purifiers, and I can definitely say those are not really good for you. And if you're interested in, learning more about these different kinds of air purification systems, I would really recommend going to this website. It's EPA. If you look for US EPA indoor air quality, they give a really nice description on what are the kinds of filters and what they do and not do. I mean, I'm in no capacity able to recommend which ones are good or bad, but just knowing which one works with which principle might help you decide. Yeah.
Is there anything similar for masks to sort of provide guidance on?
There are some basic. I think Delhi Air had. So www.delhiair.org, if I'm not mistaken, they had an article about what to look for, and they speak about similar things like go for N95 and N99, make sure the mask fits you well, and it also has a list of links where there is more information about types of face masks, so you can look it up there. So finally, the other question is, I can buy a face mask, and I'm pretty sure everyone in this room can buy a face mask and an air purifier, one for every room in their house. But the person, who lives in a one-bedroom apartment with no windows probably cannot buy either of those. So somehow we have to start thinking in that respect also that, we are able to afford ways in which we can reduce our exposures. We can limit ourselves to our homes where the air purifiers are running 24/7, but not everyone is able to do that. And this becomes, again, particularly relevant in the Indian context because we do have a huge section of the population that is not, in the category where they're able to either be mindful of these things. So, they have so much going on that air pollution, really high air pollution, is probably way down on their list of priorities. So we have to start thinking of it also in terms of, is it something that needs to be done just in terms of, whether it is a just process or not? Like, should these exposures be controlled because we have this huge population that is not able to protect itself? And, what comes to mind is George Orwell's Animal Farm, like all animals are equal, but some are more equal than others. I think that's, some of that is happening. Like, we are able to protect ourselves, so we are more equal, but what about all those who are not? And I haven't seen our air pollution discussions sort of go in that direction. Maybe they are going. The only article that I found, and it was in The Garden, was, that Delhi's air pollution is a classic case of environmental justice. But I think if we have to talk about community engagement and trying to get the government to act, maybe this is one of the ways in which we can formulate our argument and say, well, this is a bigger issue than just, a few of us who know what air pollution is, and it is really bad. So I just wanted to put it out there and say, let's talk a little bit more about this. Did you have a question? Okay.
Actually, hasn't air there also been the argument that is poor people contributing to the air pollution problems? I think it's almost the opposite, the flip side of this, that there may have been more discussion about.
Yes, so I mean, I agree. There is a lot of discussion. And even, when we talk about burning solid fuels, burning the crops, we are always saying, oh, all these, farmers are burning these crops. And what about our health? The thing is, the people who burnt the crops are living in that same area, maybe within a few kilometers. So whatever effects we felt here, they felt it worse than us. And there are studies that have looked at this in a lot of detail. And I do agree that, to some extent, we can say that those are the people that are, burning waste in the winter or using solid fuels for heating in winter. But the question is, what else are they supposed to do? They're not going to sit there, shiver all night because, oh, I don't have heating. I don't have an electric heater, or I can't afford an electric heater. What do? I'm going to do whatever it takes to survive through the night. And I think we have to walk a very fine line here, trying to, pose these arguments. I mean, I don't want to sound like someone that says, oh, rich people need to stop whining. I don't want to be the person that says poor people need to stop, doing all this stuff. But I think as a community, we need to find that perfect balance where we say, okay, these are the problems, but why do they exist and what can we do to solve them? Yeah.
Well, I mean, rich people are turning on air purifiers using electricity from power plants that have no scrubbers or SCRs. So in terms of total pollution load, and riding around in a vehicle with air conditioning as a solution to pollution is simply providing pollution to others.
Yes.
And as Sarath Godikunda points out all the time, if waste were collected, poor people would not be burning it.
Exactly.
So wealthy people are responsible for most of the pollution.
Yeah. And I mean, it's also a bigger argument at the global scale. If we look at air pollution, I mean, forget about Delhi or solid fuels. There is a lot of industrial air pollution in India. And, some of it is industries that have moved from the developed countries to India or, other countries in the world. And, it's a very difficult line to go for, because if I start saying today that we need to shut down these industries because it's killing people, Modi is probably going to get really unhappy. So I'm not sure what the answer is here. I just thought I'll put it out there for all of you to, discuss and think about and maybe figure out a way to frame it so we can use it. Yep.
So you're talking about poor people and we always talk about metro cities. So we're not thinking for the smaller cities where these industries are, how they are suffering actually, and what needs to be done, because the data is not available on ground.
Yeah.
So as you see, so there needs to be, something needs to be done for them.
No, I completely agree. In fact, yesterday, Raipur, so one of the India spend monitors, and it's, a low-cost sensor, so I'm not sure how accurate it is, but if it shows 1,000 micrograms, I think it's somewhere in that range. And I got some photographs from Raipur city. There was this big pile of trash that was burning. Everything was smoky. Where are the news headlines? Because it's not Delhi, should we not talk about it? So I completely agree that we need to go beyond the Delhi system and, look at the whole country.
There might be cities which are more polluted than Delhi and Raipur.
Yeah, and we don't know. Yeah, I agree.
My personal experience, I travel in Aligarh and Delhi. You don't have to go far. It's Ghaziabad, just before entering Delhi. At night of December or January, it's all, humid.
Right.
And a thick yellow thing is surrounding you. You can't close the window.
Yeah.
You can't get down the train because you're waiting to reach the New Delhi railway station or Old Delhi railway station.
Right.
And you're just stuck. It is a kind of, gas chamber.
Right. Yeah, absolutely.
Because every compartment is not AC.
Right.
So most of the train is like that, and if so much of crowd is there inside, they have to keep the window open.
Right.
And train stops there for, sometimes for half an hour.
Yeah.
So your breathing, it's totally different.
Yeah.
I experienced it quite a time. Then I took, roadways because it became difficult for a few days. I said no more.
Right. So yeah, I mean, I think there's lots of examples in which we have personally experienced air pollution outside of Delhi. We just need to, figure out how do we maybe shift our focus a little bit, not forgetting Delhi because it is a huge city. It still has a huge problem, but just trying to redivert some of our focus towards other parts of the country. And then just to end, I have talked about what's there, what's, what we can do. So going forward, I think one of the questions that is raised a lot of times, and we touched upon it briefly, is, do we believe the data that's being put out? Is it good? Is it not good? I mean, some of it is really good. Some of it maybe not so much. So we need to figure out ways in which we can reach a standardized agreement on like, okay, this is how we do everything across the country. And that will help us generate data that would improve our mortality estimates or, just trying to model what the PM levels are going to be across the country. Also, we need, so I was talking to Dr. Gargava from Central Pollution Control Board yesterday, and he said they have plans to set up 46 air quality monitoring stations in cities with populations more than 1 million, which is great. We need to, just keep expanding the network so we improve our knowledge and we know what's happening across the country and, look at long-term trends that would also help us identify if interventions in different places are actually working or not. So if we, have an intervention that Mr. Kejriwal announces, we need to be able to say, okay, you did this, it worked to this extent, or you did this other thing and it didn't really work. Another component which I think is somewhat missing is translating science into policy. I know there is good stuff happening around the country that can be compiled and used for taking concrete policy actions, but somehow there is a disconnect. And, I was just reading the news the other day where Supreme Court gave Delhi government 48 hours to come up with an action plan. And in my personal opinion, 48 hours is not enough to come up with a plan which is sustainable, which will actually lead to long-term action. So, 48 hours, they'll probably come up with the plan and say, okay, every time the pollution levels increase, we're going to shut down this, we're going to shut down that. And that's okay for an emergency response, but that's not good enough for a long-term reduction in pollution, in pollutant levels. The other thing, which I personally think, scientists like us need to do a little bit more is engaging with people and trying to explain like all these, you just go there and say, oh, there's all this like complex chemistry happening, but maybe we need to go out and say, well, this is what it means and this is what it means in terms of health. And I'm hoping that, people in this room would help figure out ways in which we can increase awareness and, engage more people, because that will also help push the government, because unless we demand it consistently, I don't think we are going to get good air quality. And finally, I think we definitely need more capacity, not just in science, but also, in terms of people who are operating these air quality monitoring stations, people who are reporting on air pollution or, environmental issues in general, the policymakers and the politicians who have to finally make these decisions. You and I are not taking the decisions, the government is taking it, so we just need to find ways to help them understand these issues better also. And to end, I will just, let you guys read this cartoon for a minute. And I think some media reports recently suggested installing air purifiers at traffic intersections. Personally, I don't think that's going to do much for the city. It's just another technology fix, probably not very useful. And this, cartoon actually came out in 2010 when the government was preparing for the Commonwealth Games, and they set up a purifier in, I think, CP. It didn't work, wasn't effective, but 6 years later, we're back to the same, argument, like, oh, maybe we should just install air purifiers. But I think now they were saying, like, traffic intersections and, yeah, to help, like, clean the air. So yeah, I mean, I don't think that's a reasonable solution, but hopefully the government will take note, and I don't think they are going forward with it, as far as I know. So with that, I would like to end and just point out that if you are interested in air quality issues, find this website. You will find like news pieces, but also like research articles on air pollution from India, where you can see what scientists are actually doing. It's it shouldn't be the space where no one knows where all the money goes. Very little money, but some money does go to research, and we should know what is really happening. And if you have any questions or would like to discuss things further, please feel free to email me, talk to me, and thank you so much.
We do have 5 minutes, so is there any questions?
Yeah.
Thanks for that fantastic and thought-provoking talk. My question, or more like a comment, I think, is when we talk about PM 2.5, especially in India, and actually like around the world, there is this kind of competition angle to it. Like, Delhi is the worst, or, like, oh, it's 3,800 micrograms per meter cube, it's 1,000 micrograms per meter cube. And I think the small detail is lost that even when it's monsoon here, which is like the cleanest time of the year, it's like 50 micrograms per meter cube. And I think bringing in a technicality, which is that the dose response curves or the health implications are not linear, which is a good thing, because if they were, we would all be dead.
Yeah.
And it's also a bad thing, because if we have to go down these curves, you have to go on that flat path first and then come back.
Yeah.
No,
I completely agree with you. And, I mean, one of the things that is also very interesting is, and it is changing, so I'm not saying, that's the same thing, but 10 years ago, if you looked at media articles on air pollution, you'd see one or two in the winter, oh, air pollution is a problem, we need to do something about it. Now we have a lot more articles in winter, but maybe only a few in the summer. Air pollution is not solved in the summer. Air quality is still bad. It's relatively good, but our relative is very different from what clean air is supposed to look like. And, as the WHO air quality guideline is also just a guideline. So if we were at 10, it doesn't mean that's good, that's safe. It's probably where you don't see a lot of health effects, but we never reach 10. We go to, the other day at the workshop, someone said, oh, the pollution levels today are hazardous, but don't worry, tomorrow they will be severe. I mean, okay, that's good news to some extent, but that doesn't change the fact that I'm still getting exposed to these really high levels. So completely agree with you. Yeah.
So if you were to sort of rank personal protective factors, the things that people can best do to protect themselves, what would they be? And then how much of a difference does it really make in the grand scheme of things?
That's a very difficult question, I would say. I think, just as a first step, just understanding what are the different things that are contributing to our exposure would really help. So, if we know that if you're cooking, open the windows. Don't try to cook, with the windows closed, or, turn on the exhaust or the ventilation if you have it. Under really bad conditions, maybe staying indoors is a good idea. And if you are staying indoors, shut the windows, because if the windows are open, everything is still coming into the house. Another thing that a lot of people have, brought up, especially I think with the half marathon coming up, is, should we really be running if the pollution levels are really high? And it's very interesting, because there was a study recently that looked at global ambient PM 2.5 levels and tried to understand what would happen if people were cycling and walking, because they're more physically active, so they're breathing in a lot more air. And Delhi was perhaps one of the only places where they said, you know what? Maybe people should not be walking and cycling outside because it's too bad. China was
Early morning joggers.
Yeah, don't go out jogging early in the morning. Go in the afternoon. Yeah.
It's exactly the kind of advice we need.
Yeah.
Yeah. So I feel like the discussion here right now is where it was in China maybe 10, 15 years ago, where everybody's spending a great deal of time talking about how to monitor better, how to measure better. And I think the more relevant numbers, I mean, because after all, we know it's bad. We know that even the lowest numbers are bad, right? Yeah. The more relevant numbers I would give you are 200 versus 18,000. That's the staff of the Central Pollution Control Board versus the US EPA.
Yeah.
Right? And you have in the United States, you have about 18,000 in the EPA and at least as many at the state and local level.
Right.
Add those together, and that's about the staff numbers total in China. Maybe there are a few more in China. In India, all told in the whole country, you have less than 6,000 people working on enforcement. And the real challenge is how do you actually get enough support to lift up to enforce rules?
Yeah, I mean, I completely agree with you. And, I think in some ways, part of our problem is also that, we have some good rules. Like, not everything that we have in this country is bad, but some of it just never gets implemented, so it leads to bad results. And I'm right there with you in, improving capacity in our pollution control boards and giving them more, power. Making them in charge of taking decisions that would help improve air is definitely important. And I think that's where a lot of the community engagement can be brought in to try and say, here's everything you can do, but then, okay, so if tomorrow the Kejriwal government decides to ban all waste burning, who's going out to check where the waste is being burned? But if you're using a remote sensing mechanism, you're able to just track it. You don't need 8,500 people going out. Maybe 50 would be a good number to start with. No, more?
You need thousands because you actually need people that go around and stop it. But actually, for the waste burning, you don't need to be punishing people. You need to be collecting the waste.
Yeah, I mean...
And you need thousands of sanitation workers to do that, right? Staffing is the most critical thing.
Yeah, agreed. And I mean, probably something we don't think about as often when we think of solutions. So, that's one lesson I'll probably take back with me and try to figure out how to push that forward. And hopefully all of you will, also find ways in which we can bring our, knowledge together to inform policy. And
concerns where, again, when we're talking about doing all these things in a developing country, the issue of costs come up, right? And I'm just interested in the trade-off between cost and accuracy. Say, for example, with air pollution sensors, would it make more sense to have a few more highly accurate sensors across, say, the metropolis and some of the towns, or should we go the streaming data way and have cheaper sensors and lots of them to sort of affect public health and the implications around it and try and improve them?
Yeah, so I think we sort of need a mix. You want to add? Yeah.
Thing. If you can tell how good these low-cost sensors are.
Right. That's okay. So the low-cost sensors can be good. Not all low-cost sensors are good, but there are some that are reasonably okay out there, that are out there and they're reasonably okay. But again, it comes back to the same thing. If you buy a $20,000 air pollution monitoring instrument, you put it out for sampling. For the first 3 months, you get great data, but no one is going back to check it. So after 6 months, it starts like deteriorating. 1 year later, whatever is coming out of that instrument, I would not believe it. And the same goes for the low-cost sensors. So if you are setting up a network, it needs to be very consistent. It needs to be calibrated properly. And, I can go into a lot of, technical details for that. But I think to answer your question, we need a stable, long-term monitoring network for the country. So we have data for specific locations in the country over 10, 50-year periods. But at the same time, we need to recognize that we cannot put air quality monitoring station every 50 kilometers. That's not going to happen. And that's where the low-cost sensors can actually help us. If we have a good network that gives us reliable data, we can use some of those large monitoring stations as our reference and go for a bigger network. This network not only helps science or policy, but it also helps people. I mean, I personally feel the low-cost sensor networks have done an immense job in making the people aware more than the DPCC or the CPCB monitors ever did. And it's because people can suddenly now, take this small sensor, put it in their house and say, wait, this number doesn't make sense. They say that it's really bad, so what does that mean for me? And it starts a dialogue, which would never start with a huge monitor that costs a lot but sits somewhere and, gives numbers. But I wouldn't go all aboard the low-cost sensor ship. I think it's a great technological resource that is cheap, would be very useful for a country like India, which is huge. We just need to be cautious about the quality of the data. And if we can come up with a way that, we standardize the methods, we say, if you have a low-cost sensor network, these are the data quality protocols that, you should follow.
To that point, that would mean that you need somebody to manage and maintain these sensors.
Absolutely, absolutely.
Able to capture the errors in the system.
And there again, the technical know-how and like staffing capacity or just having the capability to run and understand what is, what is going on within the instrument, what is what is the principle on which this instrument operates, why does it not work under certain conditions, why does it work under certain conditions is really important. And as these low-cost sensor networks, expand, I think as a scientist, I personally feel that we should, as a community of, researchers, should engage more and try to understand what the ideas are, what is being done, how is the system set up, how is the data processed, because I feel like there's this vacuum. So there is, this group of people who are interested in learning more about air quality. They're setting out these sensors. But then we are here on this other side saying, well, I don't know what the quality of the sensor is. I don't know what this data means. And we need to talk to each other and say, okay, here's this sensor, and here's this, reference monitor. Let's see what it looks like. Let's see what it looks like today, and let's see what it looks like 3 months down the line. And we need to get over some of the skepticism. As a scientist, I need to get over some of the skepticism and be willing to believe that this can work. And as, let's say an independent community initiative, they need to be willing to, give up some of the skepticism and say, well, maybe, there is a way we can work together. So I think we should not let go of this opportunity of using low-cost sensing technology, not just for air quality, but we could use it for water quality, we could use it for noise, which I think is one of the most overlooked things. And noise is really bad for us. And in Indian cities, I mean, every time I'm out on the road, I think that's just like so irritating. I'm like, I don't care if air pollution is bad, I'll roll up the windows, but where does the noise go? It's still there. So there are a lot of opportunities, and we shouldn't, try to prove one over the other. We should try to find a way we can merge the two together and say, this is reasonable, this is good, so let's move forward and, with that model. Yeah.
So we've talked a lot about this gap in data. I'm wondering, once we do have this data, what can we use? Like, say there's like a bunch of sensors across the city. Like, what can we then do with that? What will researchers envision doing with that data?
So there are a lot of different things you can do with this data. One, obvious use would be to try and understand what is driving the local air quality. So maybe you can, if you're using a network of sensors within a 50-kilometer grid or even a 10-kilometer grid, you can now start pinpointing at this time of the day, something's going on here. What is it? Because that's what drives up the pollution levels. So let's try and target on that one thing, and then that will bring down the levels in that region. Another thing is we could try to, make a whole group of people, so it doesn't just have to be scientists anymore, and 50 people doing air pollution research across the country. It can be 800 people, 800,000 people, who have these sensors, and the richness of data can help us answer a lot of the questions. So, what is the regional contribution to Delhi's air quality versus what is the local Delhi contribution? Honestly, we don't have a good and a clear answer to that question, which we can with, networks like those. Yeah.
Following up on that, at the moment, do you have any sense of to what you can attribute the air pollution? How much is coming from waste burning versus how much is coming from crop burning versus how much is coming from the cars, et cetera, et cetera?
So the crop burning is a very seasonal source. It's not happening all year round. It's definitely a big contributor in the winter. I think I would hesitate to put a number on it off the top of my head. I can say that traffic on average across Delhi, somewhere between 15 to 25% higher in some places, lower in some. There are slight variations in the seasonal, so you might get a slightly higher or a lower number in summer versus winter, but it's somewhere in that range. Dust, all kinds of dust included, probably somewhere around, again, 15 to 30%, depending on the site and the area. High in winter, but very much lower. Sorry, high in summer, but very low in winter. So the contribution from dust in the winter is almost nothing. The other sort of big source, which we sometimes don't talk about, is the brick kilns, which are around Delhi. So none of them are in the city, so we don't talk about them as much, but they're all around the city, and they burn a lot of biomass, some amount of coal, and they can really increase the pollution levels just, as an overall area. And again, that is a seasonal source that is not happening all year round. The brick kilns operate on certain cycles, so they would run for a few months, and then, they would shut down for the season. So there are a lot of these things that really add complexity. And so far, most studies have tried to look at the very traditional, what's the contribution of coal and traffic, and which is why we have very mixed results in terms of what is this coming from. Okay.
If there are still any questions, perhaps you could take it offline. But I'd like to thank Pallavi for a wonderful presentation. I'm sure all of us learned many new things today. And for being so patient with so many questions and interjections. So thank you.
Thanks. Thank you very much.